In this video, we're going to start looking at terminology related to Lewis structures for molecular compounds specifically. So in the last video, you learned that ionic compounds form by a transfer of electrons. In this lesson, we're going to learn about how molecular compounds form. And rather than transfer electrons, they form by electron sharing. Electron sharing. And that's primarily because the electronegativity difference between the atoms that are participating in the bond is not very large. So it's not large enough to have a substance pull away an electron completely. So they'll end up sharing it instead. So covalent bonds is what we see in molecular compounds, and a covalent bond is really what's involved when they have sharing of electrons. And specifically, we mean the valence electrons. Usually, for the most part, it's going to form between two or more nonmetals. 2 plus means two or more nonmetals. There are some exceptions where you might see a metal form a covalent bond with a nonmetal, which is why you would need to actually use your electronegativity difference to figure out if you actually have a covalent bond or not, but it's very rare. Either way, we are always going to try to confirm what type of bond we have using our electronegativity difference. You know you have a covalent bond when your electronegativity difference is less than 1.7. And remember, electronegativity difference can never be a negative value. So let's just take a look at this image over here. Here we have hydrogen and we have chlorine. Notice the chlorine has 7 valence electrons and the hydrogen has 1. In the previous example, we saw, well, an electron would be transferred from the metal to the nonmetal, but we don't have a metal here. We only have we have 2 nonmetals. And we're going to calculate the electronegativity difference to see if a transfer will happen or a share will happen. So if we find chlorine, remember from your periodic table over here, chlorine is 3.0 and hydrogen is 2.1. So we have 3.0 minus 2.1 is 0.9. That 0.9 is less than 1.7, so we have a covalent bond that's going to form. It's going to be a share rather than a transfer. So hydrogen, remember, only needs 2 electrons for its complete valence shell, and this needs chlorine needs 8 electrons for its complete valence shell. The reason hydrogen only needs 2 is because it only has 1 shell. So what's going to happen is they're going to come together and share electrons to get a complete set. Hydrogen will say, well, I notice you have an unpaired electron over here. And chlorine will say, well, I notice you have an unpaired electron. And hydrogen will say, well, why don't we just kind of combine up our collection? And so technically, if I'm sharing 1 with you, I now have 1 from you and 1 from me, that's 2. And if you're sharing 1 with me, well, you have 1, 2, 3, 4, 5, 6, 7 of your own, plus the 1 you're sharing with me, that's a total of 8 that you have. So now you're happy as well. And so chlorine and hydrogen don't have a high enough electronegativity difference, or chlorine can say, no, I'm not sharing, I'm just taking yours, leave me alone. But it's different. So what they'll do instead is they'll decide to share. So here they're sharing a pair. Usually electrons are shared in pairs. And we can represent that shared pair using a line as well. And so we'll go over what the line means. At the same time, it means we're sharing a pair of electrons. So you can see the same process here. We have the hydrogen wanting to share with the chlorine, and that's what they end up doing. So we can see our shared pair over here. And so for hydrogen, that's 1 from itself plus 1 from the chlorine. It's 2 total. From chlorine, there's 1, 2, 3, 4, 5, 6, 7, the X's from itself, and then 1 from the hydrogen, so that's 8 total. And so we can see all these different representations of the covalent bond that form between the H and the Cl. So before we learn how to draw these in more details ourselves, we're going to need to learn some important terminology. So first and foremost, there's bonded pairs. Those are the shared pairs of electrons. So the electrons are actually found within the bond. So for example, if we look at this image here, this is a bonded pair. Bonded pair. It's found between the bond of nitrogen and hydrogen, or between those atoms. This is another bonded pair. and this is another bonded pair. There are some electrons that don't participate in bonds. So for example, if you look at the electrons over here that are just at the bottom of nitrogen, they're not within a bond. So we call those non-bonded or lone pairs. They're alone, lone pairs. They're not participating in a bond. Now, when it comes to bonded electrons, you can actually form several types. You can form single bonds, double bonds, or triple bonds. These are all still covalent. It's just a matter of how many electrons are you sharing in that bond. If you have one line, like we have over here, that's called a single bond, and that's two shared electrons, or one pair. Okay, so here we have a single bond in the water molecule and another single bond over here. So we have two single bonds. There's two electrons being shared in this bond, and then there's two electrons being shared in the other single bond there. Sometimes you might see two lines between atoms, and two lines would basically mean just four shared electrons. So that's called a double bond. So here we have a double bond, double, and that's four electrons being shared, or two pairs. Okay, so here's another double, and so that's four electrons being shared. And you can see that here, four electrons shared between carbon and oxygen. Same idea here. And over here you can see two electrons being shared, two electrons being shared. And you can see on the oxygen you have a lone pair there and a lone pair there. So the ones that aren't in bonds are the lone pairs. And lastly, you could have three lines, and that's called a triple bond. And as you can see, each line counts as two. So three lines would be six electrons that are being shared between the atoms. So here we have one triple bond. And that basically means just six electrons shared between them. And you can see that over here, six electrons. There's two lone pairs, one lone pair here and one lone pair over here. So that's important terminology because when we draw Lewis structures for molecular compounds involving covalent bonding, you'll have to pay attention to bonded pairs and lone pairs and use that terminology in your process. So we'll do a couple practice problems together. The first one, we're going to label the bonds that are indicated here as either single, double, or triple bonds. So we'll start off over here. Let's look at this one right here. You can pause the video and try it yourself. That's a single line between the C and the H. So this C and this H are sharing two electrons. So single bond. And there's many single bonds on this carbon. There's a single bond here, a single bond there, a single bond here, and a single bond here. But that's okay. This one here is just a single bond on its own. Next, we'll start with we'll go to the one with two lines. So there's two lines between these two carbons, and this is a double bond. Double bond, and that's four electrons. And lastly, we have three lines here. So we have a triple bond. That means that six electrons being shared between these carbons over here. And now we'll go off to the next question. We want to draw bonding electrons in the molecules as single bonds, double bonds, or triple bonds. So basically we want to replace the bonding electrons, the dots, as lines. So here we have two electrons being shared. So, and same thing over here. All those electrons are being shared, two, two, two. So between each atom, so we have hydrogen, two electrons there, we'll put a line. The bottom one has two electrons, we'll put a line. In between the two carbons is two electrons, we'll put a line. We have a line over here, a line over here, a line over here, and a line over here. And you're probably already noticing some patterns. Hydrogen only ever has one line connected to it, and carbon can have up to four lines connected to it. Let's take a look over here. So we'll start with our carbons. The hydrogen on top there has one line. The hydrogen at the bottom, one line, because there's only two electrons between them. Now between the carbons, there's actually two lines since there's four electrons. And then after that, we have one line and one line. But notice each carbon has a total of four lines. 1, 2, 3, 4. And this carbon here, 1, 2, 3, 4. And now we'll try this one here. So you can, again, try to pause the video and try it yourself. So I'll start between the carbon and hydrogen. We have a single bond there. Between the two carbons, we have 6 electrons. So that's 3. Let's try that again. That's 3 lines. And then finally, our last line there for the carbon and the hydrogen over here. And so this is how we would represent electrons participating in bonds. You can draw them as their dots, but typically we will ask you to just connect them with the appropriate lines. Those lines, single, double, and triple bonds, are still covalent bonds, just it depends on the number of electrons being shared within those bonds. And so in the next video, we're going to take a look at how to draw Lewis structures for molecules involving covalent bonding. So at this point, you should be able to go through these examples and understand the different types of bonds that we discussed, understand what a lone pair is, what a shared pair, what a bonded pair is, and you should be able to explain these various images. There are others that you can take a look at just to enhance your understanding of bonding as it occurs.